Okay, for this video, we will focus on going through the harder question for your paper 2 N level 2018 paper. Okay, so please take note, this is for 2018 N level paper. So let's look into this. Okay, for question 1, basically you can find your answer from the EM spectrum chapter. So I'm not going to cover too much. So let's move on to question 2. Okay, question 2 is about this thing that is new to some of you. It is called the ticker tape timer. I will show you a video on how it looks like. So this is a ticker tape timer.
Use of ticker tape timer.
So I will skip this part first.
Trolley, meter rule, and ticker tape.
So basically this is the ticker. So what it does is that you can see there's a pin on it, and the pin will basically keep on punching into the metal plate. So it will punch hole at a certain time interval.
The ticker tape timer has a circular piece of carbon paper from the left under the carbon paper.
So then the white color is the tape.
To the trolley.
So when the trolley go forward, it will actually pull the tape along. So now the ticker is ticking. And as it's being pulled along, you can see that it leaves marks on the tape. So actually we can find out how quickly the trolley actually moves. So at the beginning, as the trolley has a very small low speed, you can see the ticker dots are very close to one another because the tape is not being pulled along very quickly. Okay, but as it speeds up, you can see that the gap between the two dots on the left is getting wider. So let's rewind and take a look.
So as you can
see, it moves, and then once it moves, it will leave like that. Can? So now this is the ticker tape that we are getting. So as you can see down here, the gap is actually small, but then at the end, the gap is actually getting wider. So we can say that the trolley over here is moving at a very slow speed, but down here is getting faster. Yeah, so we can say that basically the trolley is accelerating. And basically because we know that the ticker makes a dot every 0.02 seconds. So meaning that the time taken to place these two dots is 0.02 seconds. And we can actually tell how much time has passed when the trolley moved from A to G by counting the interval in between. So 1, 2, 3, 4, 5, 6. So the total time taken for the trolley to go from A to G will be 6 times 0.02. Okay, so basically that's how you read the ticker tape. So let's answer the question here. From the information given, what conclusion can I make about the motion? So like I said, if you look at the gap, it is getting wider and wider, meaning that within the same amount of time, 0.02 seconds, my trolley must have moved a larger and larger and larger and larger distance. So it means that the trolley must have been accelerating. So what I can conclude, number one, is that the trolley is accelerating. That is my conclusion. And how can I tell? I can tell it because the gap between consecutive dots are getting wider. Yeah. Then after that, I need to measure. When you see the word measure, meaning that you really need to put a ruler there, and then record the distance traveled between the dot E and F, and give your answer to 1 dp. So for here, I can't do it because my page is not of a fixed scale, so I cannot measure, but you should put a ruler between E and F and measure this in cm and leave your answer in 1 dp. So once you know that, you can actually calculate the average speed between E and F. So let's say down here you got a number, let's give ourselves a good estimate. If I put a ruler there, let's say 3 cm, let's say, so I will give a dummy value. So let's say this is 3.0. So average speed is given by the distance divided by time. So always write down the formula. So the distance here, we say this is a dummy value divided by the time. So how much time has been taken to travel from E to F? It is between 2 dots, right? So it means that it is only between one interval. So therefore down here will be your 0.02. Sorry about the ugly wording, so let's write it properly, and then you will get the answer. Okay, and you can put it here, and it is fine because it is cm per seconds. Okay, so down here is another question on electricity and heating. So what is the effect? This one I leave it to you to try. Practical use, I think this one you can figure it out also. I will leave it to you to try. I will mark your paper. To draw the conventional current, so always remember conventional current is flowing from positive to negative. So this one I will give you a hint and then I will mark for you. So just remember it's from the positive terminal of the battery to the negative terminal of the battery. Okay, and don't forget to answer this question. You need to draw on the diagram position of a component that is used to measure the voltage of a battery. So the equipment must be a voltmeter, and remember voltmeter has 2 arms. I want you to connect and show me. Okay, you are measuring the voltage of the battery. Yep. So down here, you are supposed to tell me the reading on an ammeter. You need to know that ammeter actually measures the current I. When you see this 60C, it is actually referring to Q. And then you have this timing, 2 minutes. Remember to convert this into seconds. And basically this will tell you the T. So in this question, you have the Q, you have the T, you're supposed to find I. So go and use the correct formula. Look at your formula sheet. Okay, let's move on to your question 4. This one is to test whether you can read a graph properly and interpret it. So for part A, I think you should be able to solve. For part B, don't panic. This sodium chloride basically is here. You can read it from the graph. And for it to freeze, it means that it is changing from your freezing. It means the temperature at which it freezes. So you need to know that basically the freezing point is the same as your melting point. Okay, because down here you have solid to liquid. So where is the melting point? Find out where is the melting point, and you can actually after you find the melting point from the graph, you can then find the freezing point. Okay, they are the same, so you need to know that. So this is your content knowledge. Okay, so we have reached section B. So for revision sake, we will just do all the questions rather than to pick 2 questions out of it. So question 5 is your typical database question. As you can see, some data is given to you. So what happened is that before we go into the question, I think it is worth spending some time talking about what has actually happened. So basically, when the metal ball is being dropped through oil, there will be two forces acting on it. One would be the weight, which is fixed because it is equals to the mass times gravity. So this is a fixed downward force. And as it drops, it will speed up, and I would have a resistive force that is acting upward, and this force basically will increase with speed. So at the very beginning, when you first drop the metal ball, actually you will have speed equals to 0. So at this point, your only force acting on it will be the weight. But as it goes down, the speed down here will actually increases. And as the speed increases, then the resistance will go up. And there will be a point in time whereby the weight is equals to the resistance. Now, why is this interesting? Because if we look at the net force, the resultant force acting on this object, it is actually consists of the weight minus the resistance, which is R. And we know that the F net is equals to m times A. This is your Newton's second law. So if we write down both the left and right hand side, we will have an expression that looks like that. So meaning that when your resistance, which is a changing force, and it increases with speed, right? So it can increase from 0 all the way till it matches the weight. So when your R equals to W, then your expression will become this. And you will see that your MA will become 0. So down here, what happens is that this happens when your R increases from 0 until it matches the weight. So when this happens, you will see that the acceleration becomes 0 and your metal ball will actually move at a constant speed. And this is what we call the terminal velocity. So basically, this question is to test you whether you understand there are two forces acting on the object. One of it is the weight, which is fixed, and the other opposing force will actually increase with the speed. And when the resistance becomes so large that it is equals to the weight, then acceleration will become 0 and your speed is constant. Okay, so that is the backstory of this question. So let's look at what they want us to do. So they gave us a set of reading on the distance that the ball is traveling. And you can see that they ask you to plot. So when you plot the points, if you plot it correctly, you will see that it has a curve down here. And after that, it will have a straight line portion. So you need to show this portion. And if you are doing it correctly, you will be able to see that it becomes a straight line. That means when the speed becomes uniform. When the speed becomes uniform, it means that after, for example, 1 second, the increase here is about how much? So this is 5, right? So if I look at this set of data, after 1 second, right, the speed increased by 15. After 1 second, the speed increased by another 15 cm. So that's why down here, you can see that the speed has become constant, or in this case, uniform. Okay. So after that, they ask you to actually sketch a second line, but this time round with thicker oil. So when you have thicker oil, what happens is that your resistance will actually increase at a faster manner. So it means that this R over here would have a larger value and it will increase quicker to match the W. So in this case, it means that it would reach the constant speed at an earlier time. So down here, you would need to first draw a straight line, maybe like that. Yeah. Then from here, you can then sketch out a curve like that. So this will be the B part 1. Okay, as long as the straight line portion start at an earlier time, and you must show that the straight line is actually less steep than your original line, which is now highlighted in blue. Then after that, just curve it back to 0 and you will get the 1 mark. And of course, you need to label the line L. So I shouldn't label as B part 1 but L. And now I have to explain why is it that I will reach constant speed at an earlier time and why the speed is less steep. So let's explain. So with thicker oil, the resistance force acting on the object. What is the object name? Is it a ball? Yeah, on the ball will increase quicker with speed. Hence, it reach constant speed at an earlier time. Yep, and that will be the answer. Okay, then now I have a third experiment whereby I have a ball with the same mass. That means the downward weight is the same, but the shape will be larger. So if I have a larger diameter, I will catch more oil and the resistive force will again be increasing at a faster rate. So down here, what is the instrument? Most likely it will be your vernier caliper, so that you can measure the diameter. The larger metal ball takes a longer time to fall through certain distance through oil. Suggest why? Well, you just need to say what I have covered. A larger diameter will increase the resistive or the resistant force acting on the ball by the oil as the ball moves through the oil. So it is just 1 mark, but they give you 4 lines to explain. So they expect more details. Then for question 6, I think for part A, you can figure out what it is. So for part B, B part 1, you are actually asked to find a suitable fuse, and the hint given to you is this power rating. So like I said, you need to remember the formula, which is your P equals to V times I. We already know the P, which is 2006, and you will have 240 here and I. So I forgot to mention why is it that you need to use this formula, because you want to find the correct fuse. So basically your fuse is being limited by the fuse rating, which is the amount of current that the fuse will allow it to flow through without the fuse wire melting. So that's why we need to use the power rating to find out what is your current, which is your I. So from here you can actually find out what is your I, like that, and by punching it into the calculator, you can actually find the answer is 10.8. So this is the amount of current that the appliances would require. So I need 10.8 to run properly. So what is the correct fuse rating that you should choose, okay, in order to protect the circuit while allowing it to work? Okay, so that is your B part 1. So for B part 2, you are given a new rating. So from this new rating, you can use back the same method to actually find out what is the operating current and choose the fuse again. So I will leave that to you to do. Okay, for part C, you are given a table with the average power used already converted to kW, and the time given to you is already in H. So down here they want you to find the energy consumption by kWh. So what is kWh? Just kW times h, no? So by multiplying these two together, you will be actually able to find out how much energy is being used. Okay, so you can complete the table by doing that, and then after that you can calculate the cost of the energy consumption. So basically what this tells you is that 19.5 cent. 19.5 cent means that it is $0.195. Okay, and you have to give your final answer in dollars. Whenever you are talking about dollars, remember it is 2 dp. Okay, and for part B, it is a simple heat transfer question, and you have to explain how the heat is being transferred from the metal pan to the water, okay, by these two methods, conduction and convection. So there are some keyword. For example, whenever you're talking about conduction, you have to talk about energy transfer by the collision of neighboring particles. Okay, and when you talk about convection, okay, this one we have done a similar question in the 2017 N-level paper, so refer to it. Okay, if you have forgotten, it looks something like, oops, sorry, something like this. Okay, remember this question from your 2017 paper, refer to it, and you will know how to describe convection. So as you can see, in both years they ask similar question. That's why we are making you do TYS, and you need to memorize. Okay, finally for question 7, you are given a bell, okay, suspended by some elastic band. So this elastic band will absorb the vibration from the bell, okay, so that the jar will not vibrate. And then after that you have a glass jar covering it, and this glass jar is linked to a vacuum pump. Okay, so now they are saying that if the vacuum pump is not on, you can actually hear the bell ringing. But if the vacuum pump is on and it removes the air, then they want to know what happened to the sound. Okay, if you are standing outside, will you be able to hear any sound from the bell if the air has been removed and now there is a vacuum? Okay, so I leave it to you to figure out whether you can hear or not. But I will talk about part 2, why do you need this elastic band. So you know that when you hear sound, when there's a vibration, and then there's a medium to transmit the vibration from the source to your ears. So for now you have removed the air. So what is the function of the elastic band? So because the bell is vibrating, if there is contact between the bell and the jar can actually sense the vibration and it will vibrate together with the bell, and you can still hear a sound. But if you put an elastic band, what happens is that when the bell vibrates, the vibration will get absorbed by this elastic band, and therefore the glass jar will not vibrate. Okay, so why is it that the bell has to be suspended rather than to be placed on a base plate? If you put your bell on the base plate, and when your bell vibrates and makes sound, the vibration can actually transmit through the base plate to the outside, because your base plate is solid and it can transmit vibration. Okay, so to explain, you have to tell me that your base plate is solid and therefore it can transmit vibration from the bell if the bell is placed on the base plate. Okay, and then if you want to elaborate more, then you can hear the sound through the faceplate. So hence sound can travel through the base plate. Okay, again you can see that to get 1 mark you need to write a lot. Okay, for part B, what you are seeing is a water drop into the water tank from the top wheel. Okay, so basically you have a droplet of water dropping into a pond of water and you are looking at it from the top. Okay, so what does this circular line represent? It's called wave front. And we say that the gap between the wavefront is basically crest. Okay, so what is between two crests? Okay, what is between two crests? You go and figure it out. Okay, down here you have a fishing boat, and then it sends a signal down to a school of fish. Okay, so a pulse of wave is sent down, and then after that it will reflect by the fish and comes back to the receiver. So this entire journey took 0.10 seconds. So you know that the speed of sound is 1500, and now you are being asked to actually find how deep is the fish. So when the sound travel within 0.10 second, it actually travel 1D, 2D. Okay, the rest you go and work it out down here. Can? Okay, for the last part, you have a stone drop into a pond, and then the wave produced travel 1.2 in 4 seconds. So here you can actually find the speed using your old school formula of distance over time. And then after that, the other formula that you should be using is V equals to F lambda, and you should be able to solve the last question.